Time dilation. In the theory of special relativity, the slowing down of a clock as determined by an observer who is in relative motion with respect to the clock. In special relativity, an observer in inertial motion has a well-defined means of determining which events occur simultaneously with a given event. A second inertial observer who is in relative motion with respect to the first, however, will disagree with the first observer regarding which events are simultaneous with that given event.
There is a set of twins, one an astronaut, the other works for mission control of NASA. The astronaut lives on a deep space trip traveling at 95% the speed of light. Upon returning, the astronaut's clock has measured 10 years, so the astronaut has aged 10 years. However, when the astronaut reunites with his earthbound twin, the astronaut sees that the twin has aged 32 years. This is explained due to the fact that the astronaut's twin is traveling at relativistic speeds and therefore his clock is slowed down. Let's see how we can calculate the time difference. The equation for calculating time dilation is as follows: T is equal to T naught by root over 1 minus V square by C square, where T is equal to time observed in the other reference frame, T naught is equal to time in observer's own frame of reference, V is equal to the speed of the moving object, C is equal to the speed of light in a vacuum. Now let's have a closer look at the equation and determine just what impact the speed of the object has on time dilation. We can see that is the velocity is small compared to the speed of light. The quantity v square by c square approaches 0 and the equation simplifies t is equal to t naught by 1, which is simply t. So at relatively slow speeds, time dilation is not a factor and Newton's laws are still applicable. Now let's look at high speeds. From the equation that as velocity increases, the quantity v square by c square approaches 1, causing the quantity 1 minus root over v square by c square. T naught becomes smaller and smaller, therefore causing the time measured by the other observer T naught become greater, thus making our time appear slower. Yeah, it's so confusing.
It relies on basic electromagnetism or a complex combination of electromagnetism and Newton's laws of motion. In fact, biological processes are slowed down. Yes, that's right, your head is slightly older than your feet.